So what we're going to start off with today are low water cutoffs and automatic feeders. We're going to find out where these things are located. We're going to find out what they do, how they're wired, the sequence of operations when they're functioning, and we're going to cover a few preventive maintenance tips on how to keep these things in good working order. Now, every boiler has what's called a normal operating water level, or NOWL. This is a very specific measurement from the floor to a certain level on the boiler where the ideal water level should be. Now, this is a very important measurement because a lot of the controls on the boiler are based off of this exact measurement. And the one most important control that works off of that measurement is your low water cutoff. Your low water cutoff is going to be placed on the side of the boiler several inches below this normal operating water line. Now, when we open up, we take the cover off of these low water cutoffs. One of the things you're going to see is a little wing nut in there, and that wing nut is going to be screwed down on a stem with a wire connected to it. And this is actually the probe that gets screwed into the block of the boiler itself, penetrating the boiler. And that probe is going to detect the water level. You will also see a couple of screw terminals on here, and you'll have different letter designations, and this is where our automatic feeder gets wired into so that these two devices can communicate with one another to maintain water level in our steam boiler. Now, on these terminals, you're going to see different number and letter designations. Now, I've seen a couple of variations of this. You might see 1, 2, P1, P2, and A, or maybe W. You might see 2, 1, P2, P1, A, or W. You may see 1, 2, 3, 4, 5. You may see N, H, C, W, and B, but regardless, you're going to see 5 terminals on there. Now, that sounds like a whole lot of jumble, even to me, as I look back and think about saying it. But the good news is that on the covers, you could pull these off, and there's always going to be a wiring diagram inside telling you what those terminals are for. And the beautiful thing is that I've noticed after a little while, all these terminals kind of do the same thing, and they're almost always arranged in the same order. Now, that's not a guarantee, which is why we're looking at the wiring diagrams inside the cover, because there are exceptions to this. But in general, if you understand what those terminals are, and I'm going to explain them to you right now, you can take a quick look at the wiring diagram and you'll get it within a few seconds once you understand this. Now, in many cases, you're going to see a jumper in there just like this one here between 2 terminals. Your 24 volts that your burner circuit is running off of is going to come into these terminals. And that jumper is there so we can feed power off of the burner circuit to the water feeder. So one of these is going to be a burner circuit, one's going to be for the water feeder. Now, if you don't have a water feeder, you won't see a wire connected there, but you'll still see a jumper. That's fine. It's not going anywhere. Now, your first 2 terminals from the left side are usually going to be the 24 volt circuit terminals you're going to need to power the automatic feeder. So one is going to be a hot and the other is going to be a neutral. Now, once in a while I come across these diagrams. You can't read them because they're so old and they're faded. One quick way to tell which one's hot and which one's neutral is that jumper we were just talking about. That jumper is a good indication that that is your hot connection for the 24 volts you need for the feeder. The other will be the common. So our low water cutoff has to communicate with our burner circuit, and so that the low water cutoff can shut down the boiler in a low water condition. And so just like our feeder that needs a hot and a neutral, the burner circuit is going to come into the low water cutoff on a hot wire and leave on a neutral. So we're going to have a hot and a neutral for our automatic feeder, and we're going to have a hot and a neutral for our burner circuit. And we can use the same jumper trick to determine which is hot and which is common on our burner circuit. Your hot wire for your water feeder and the hot wire for your burner circuit are going to come together side by side in those terminals that are connected by the jumper. Now, the remaining terminal is going to be an A or a W, and this is the 24 volt signal that the low water cutoff sends out in a low water condition, and that 24 volts goes up to the feeder and actually tells the feeder to activate. Now, what this means is when the boiler is not in a low water condition, when there is a satisfactory amount of water in the boiler, there will not be any power on this A or W terminal. This only happens when the low water cutoff is activated. So if you were to test for power there and you don't have power, either the water level is where it's supposed to be, there's something wrong with the low water cutoff itself, or you're not actually getting power from the burner circuit into the low water cutoff. So there's something going on prior to that before it gets there. Now our automatic feeder is usually located on a 1/2 inch diameter copper line that taps into what is called a wet return. A wet return is piping near our boiler that's very low down to the bottom of the boiler. Now what this is as the steam makes its way up through the system in the house and makes it up to the radiators, the steam will condense and turn back into water, and that water drains back down into the boiler through this wet return, through your Hartford loop, and back into the boiler again. Now this arrangement is typical in what's called a 2-pipe system. This is when you have one pipe going into the radiator full of steam, and then you have another pipe coming out of the radiator with condensate. There are counterflow systems where you just have one pipe going up to a radiator and that's carrying the steam up with it, as well as taking the water back in the same pipe. Now there's something I will cover in the piping and plumbing video when we get to that. Which reminds me, I found out that every time somebody subscribes to Jersey Mike, an angel gets his wing.
Get me! I'm giving out wings!
So don't be a dick. Give the angel his wings. Now when you pull the cover off of the automatic feeder, you're going to find 3 terminals there. You're going to find a neutral, a hot, and your feed connection, and this will be labeled NH and either feed or A or W. And just like in our low water cutoff, the hot and the neutral get wired there, and your 24-volt signal that comes off of the A or W terminal from your low water cutoff gets wired into the feed A or W terminal on the automatic feeder. The sequence of operation here is the burner circuit has to run through this low water cutoff, as I mentioned before. Now when there is a low water condition, the low water cutoff interrupts this circuit and the boiler shuts down. It also puts 24 volts on that A or W terminal to send it up to the water feeder, and the water feeder will receive that 24 volts. Now sometimes you'll have a water feeder that activates immediately, but other times you may actually have a delay, and this is because inside of the low water cutoff you'll actually have a series of dip switches. These dip switches actually have 2 different settings. There's 2 different sets of them. On the upper bank of dip switches, it is a time delay, and this is the amount of time the feeder will wait once it gets that signal from the low water cutoff before it actually starts feeding water in. Now there is a purpose for this. Earlier I mentioned the wet return. Now this is the lowest part in the boiler, and that tends to be the one place where all the gook and the grime in the system tends to settle in. So sometimes it takes a little time for that water and the condensate and all the piping and the lines to actually make its way back to the boiler. You need a little time for that stuff to settle down and feed back in, whether it's clean or dirty. So the purpose of the time delay is to give the feeder enough time to wait for all this water to make its way back into the boiler before it actually starts feeding, because if it doesn't, if it feeds before then, it may actually overfill the boiler. Because the wet return is a common place for a lot of this gook to settle in, one good preventive maintenance practice is to flush this part of the piping out periodically, and there should be a ball valve located very low at a low point in which you can open up and flush this water out. Now the lower bank of dip switches is a setting to determine how much water we're actually going to feed in the boiler. The feeder does not put enough water into the boiler on that low water cutoff setting to bring the boiler back up to its normal operating water level. In this case, we would have to actually go to the other settings on the dip switches, which are rated by gallons. So basically what we're doing is we're timing how long it would take from the moment the feeder begins to the time the operating level on the boiler is where it's supposed to be in minutes, and we would kind of round that off into gallons. So if it took 3 minutes from the time the feeder starts to the time we reach normal operating water level on the boiler, we would set it to a 3-gallon setting. But in most cases it's not necessary. You just use the low water cutoff and it's enough. Now, one last maintenance practice I'll share with you real quick before we go is actually cleaning the probe on the low water cutoff itself. To do this, you're going to remove this wing nut and you're going to take the wire off, and don't lose that wing nut. And what you'll do is you'll see screws in the back there that are connected to either the bolt or a plate of the low water cutoff itself. You're going to remove those screws and the whole entire control will come off of the low water cutoff probe. From there, you would put a pipe wrench on it and just pull it out of the boiler. Now don't forget, you got to take the water level down below that point before you do this, otherwise you're going to have water gushing out of there. Now the last time I did this, we needed 2 guys to lean on a pipe wrench to get it out, so it's probably not going to be easy. And when you put it back in, I like to use pipe dope, but if you use Teflon tape, don't use a lot of it. Use very little bit, because the threads on your probe actually use the block of the boiler as a grounding source. So if you put too many layers of Teflon tape on there, it's going to insulate it and your control isn't going to be properly grounded. So that's all I got for you today. I hope you guys learned a lot from watching this, and we're going to jump into the next one soon. Thanks for watching.